Okay, so now I'm going back to data centers. If you remember the video where Popeye covered data centers, you need to go back and watch that video. But in this one, I'll be considering internet exchange points as well, and you'll see how they work together with data centers, right? So internet or data centers with internet exchange points, which are known as IXPs, are very critical in the internet infrastructure or network architect or internet architecture rather. Remember, this is mainly focused on internet architecture from backbone networks all the way, right? We're still focusing on trying to understand or unpack the architecture or the design or the layered and hierarchical design of the internet. So these two, the data centers as well as internet exchange points or IXPs, are very critical in the internet architecture, right? They're essential because they ensure that data is processed and stored as well as routed efficiently, which enables, um, fast or higher speeds, enables reliability as well as cost-effective uh, internet access or internet services or internet connectivity worldwide. So these remember the backbone networks, the regional networks, as well as access networks. While so those networks, backbone, regional, and access networks, they carry traffic. Whereas on the other hand, data centers, they host the services which the traffic is generated from. And then you have internet exchange points that are there to optimize the flow of traffic in between different networks, right? So we've considered backbone networks, regional as well as access networks. Now we have data centers that host services as well as IXPs or internet exchange points, right? So when you go back to data centers, I've said that the way you explain or the way data centers are is that these facilities that are designed to or house servers, they house networking equipment, storage systems or storage devices, they house power supply systems, you name it, right? And they're intended mainly to process data, to store data, as well as deliver digital services to end users. And data centers, like I mentioned before, they host various services, right? There's a number of them, and the list is not limited to what I would mention, but it is extensive, right? But I'll just mention a few. So data centers host various services, including websites, web applications as well, including cloud computing, whether it's software as a platform, whether it's platform, no, software as a service rather, platform as a service as well as infrastructure as a service. Those are cloud computing services. So it hosts those cloud computing services. Not only that, but also email or as well as communication platforms, streaming services or streaming platforms, you name it, financial services, online banking, the list goes on and on and on, including social media platforms that are widely used, in today's modern world, right? So remember that they have things like servers, or they house servers, they house, storage um, systems as well. So they have several components that make up a data center, things that are critical in the data center, any data center, and I'll go into the different types of data centers or revisit the types of data centers like I did before in that video where I covered data centers, right? So go back and watch that video and then come back here. Then you'll understand or have more understanding, greater understanding of data centers, right? So data centers, we know that we understand that they house, they have multiple servers, hundreds of servers, and those servers are just powerful computers, like I've said. They're powerful computers which are there to to process as well as to store digital data, right? And they run applications, they run databases, they run virtual machines, etc. Many applications. Um, ran by servers. in a data center. And then you have, storage systems like your hard drives. Remember the SSD arrays? Yeah, even SSD arrays, for long term as well as for short term, data storage, as well as databases as well. And all those storage systems, they support redundancy, and we've come to understand that redundancy is actually an important feature of the internet, because things can fail, right? And you need traffic to be, rerouted, or you need extra backup. So these storage systems, they support redundancy as well as backup solutions. Not only that, you have networking equipment in a data center, right? That includes core as well as edge switches, routers, whatever you want to call them, um, as well as, firewalls, you name it, right? Different networking equipment in the data center, and that's intended to, connect the internal servers, the hundreds of servers inside the facility, connect those internal servers to the external external networks, or the internet itself, right? Then there are cooling systems. You find cooling systems that which are there to prevent overheating. That overheating can, arise from the high density of server racks, right? And in order to prevent over things like overheating, and or the cooling systems that are there, it's like the use of air conditioners, liquid cooling, things like airflow management as well, and other cooling systems which are used in the data center. More than that, there are the power supply systems that include, remember the uninterruptible power supplies, or UPS units. Those are for, short-term backup. And then you have generators, as well as redundant power lines, which are for, long-term reliability. So they provide power supply in these facilities, to power up this service, to power up the world, the internet, right? And more than that, there are security systems, which can be physical as well as, cyber security measures. And say physical security would include things like biometric access in the data center. There are surveillance cameras, there are guards, and other physical measures in the data center. And then when it comes to cybersecurity, you have things like firewalls, if data encryption, there is intrusion detection, you name it, different cybersecurity measures, right? So those are the typical things that would be found in a data center, or what would make up a data center, right? And I've said that I would classify again the types of data centers that are there in the whole world, right, around the world. And data centers that are there is, remember the enterprise data centers. Those enterprise data centers are usually operated by a single company or a single organization for internal operations, right? Enterprise data centers are usually for internal operations for a single company, right? Then besides them, there are co-location data centers. Those ones, they just rent, space, or only space. They rent power as well as connectivity to multiple customers or multiple businesses. What's going on? Yeah, to multiple businesses. And then besides that, there you have cloud data centers, and those cloud data centers are usually operated by, cloud providers like AWS, Azure, as well as Google Cloud, right? And all those cloud providers, they serve global customers with, scalable computing resources. And uh, another type of data centers is edge data centers, and those are typically, in close proximity or located closer to the user in order to reduce things like latency. I've said that in the video which relates to data centers, right? Go back and watch that. And these edge data centers, they support modern applications like 5G, mobile broadband, whatever, uh, IoT devices, or IoT. IoT is the Internet of Things, as well as, video streaming applications, many applications. So they host all these modern applications, or modern services, rather. Um, so the reason why data centers are crucial, the reason why they're important is because they provide somehow centralized storage as well as computing for internet services. That's number one, right? Number two is that what's this? I remember as I go along. But moving on to internet exchange points or IXPs. IXPs are physical infrastructures that are designed for multiple ISPs or internet service providers as well as other networks to connect in order to exchange traffic locally. So IXPs or internet exchange points are physical infrastructure where these service providers and other networks connect in order to change traffic locally, right? And IXPs are important because they reduce the need for regional traffic or traffic in general to travel all the way or over long distances onto backbone networks or the internet backbone itself. Whenever I refer to backbone networks, I'm specifically referring to, remember, the companies that are tier one providers or that operate backbone networks like CenturyLink, Tata Communications, and NTT Communications. Remember AT and T. Those are the backbone networks which I'll be typically referring to whenever I mention like backbone networks. So um, IXPs actually reduce the need for traffic to go all the way to these companies which operate backbone networks, right? So the typical features of IXPs or internet exchange points are that they have local traffic exchange, and that simply means that local ISPs can exchange traffic. They can exchange traffic, and the traffic comes from the same can come from the same city or from the same region. So they exchange the traffic, which actually reduces the dependency on backbone networks, right? So IXPs also reduce latency because now, since they exchange traffic locally, data has to travel like short distances in order to reach its destination, right? So that improves the response time for users who are accessing, you know, um, internet services as well as or website, as well as other online services locally. It also reduces cost. Cost for who? Cost for the ISPs, right? Because now the there's minimum, right? There's minimum traffic that has to travel, over expensive long haul links to onto backbone networks. Right, there's less traffic that has to travel over long distances onto backbone networks, and so that reduces the cost for local ISPs, which means they have to pay low transit fees in order to exchange traffic locally, right? And it also promotes things like or it promotes resilience rather, because now this direct peering with other local ISPs or other other the networks, right, it actually increases redundancy. Remember, I've said redundancy is very important. It's an important feature because if it happens that if one link, right, if one link through a certain network which is operated in some country, if that link fails, then traffic can be rerouted through another participant in the IXP or internet exchange point, right? So those are the typical features of IXPs. So how they work or how IXPs work is that you have different networks like ISP networks, enterprise networks, as well as content provider networks, which connect to the shared switching fabric, right? And then there's the traffic that is destined for a participant in the IXP or in the internet exchange point. That that traffic is basically it's local, so it's destined for that IXP or that participant in the IXP doesn't travel. There's no need for it to travel over long distance to the internet backbone, and then it's only non-local. So there's local traffic that is exchanged locally, and then there's non-local traffic. So non-local traffic has to it's only non-local traffic that is no it's only sent upstream or up to onto these backbone networks or the core networks or the internet backbone itself. So that's how IXPs work, and the very common IXPs around the world, such as you have the 6 or DE slash um, CIX, which is in Germany. That's an internet exchange point in Germany, and it's one of the largest IXPs in the whole world. Right? It's one of the largest, as as the Afrikaner says, in the wereld, in the hele wereld, right? So they're one of the largest in the world, and you have the links or the London Internet Exchange, which is in the UK, right? It's a major European hub for internet exchange. And then you have one in Johannesburg called Jins. Jins is the Johannesburg Internet Exchange point, right? It's for local traffic in Africa, as well as you have MSK IX, which is in Moscow, Russia, and that's for usually regional traffic optimization. So those are the typical IXPs that we have around the world, and IXPs are important in the fact that um, number one is that they encourage local content hosting, right? And not only local content hosting, but as well as traffic localization, and that reduces backbone load, right? And for internet users or for end users, IXPs actually increase internet speed as well as reliability, right? And then for ISPs, as I've mentioned earlier in the video, the IXPs actually reduce costs for ISPs, and so that they pay less transit fees when exchanging traffic locally. And then for developing countries, um, consider the fact that since they allow local traffic exchange, since IXPs allow local traffic exchange, they strengthen regional internet infrastructure, especially in those developing countries. So now looking at how data centers as well as IXPs work together is that data centers are intended, to host services, right? Like cloud computing, you name it. I've mentioned the ones that the services, online services that data centers can host. So they host their services, whereas IXPs they allow local ISPs to exchange traffic with the data centers or with other local ISPs, right? So that's how they work. And then backbone as well as regional networks, they carry the non-local traffic over long distances, right? And then end users, receive faster as well as low latency internet access. So I'm in Johannesburg, right? So imagine, consider, like, let's say there's a certain video or whatever online. It's hosted, let's say it's hosted in a data center that is located here in Johannesburg. So if it's located in a data center that's in Johannesburg, let's say users in the cities around Johannesburg, let's say Cape Town or Durban or Pretoria, so those users can receive that video quickly only if the regional networks around or local networks around exchange traffic through Jinx, right? Through a Johannesburg internet exchange point, rather than setting that video onto, like, let's say, an international backbone link, right? So that would be a problem. So in the next video, I'll just mention the point that I wanted to mention before, but see you next time. But it will be on IPA based addressing and routing. See you next time. Thank you.